What's going on, everyone? Welcome back. Patrick here, and moving on to the next question, we got to find the inverse for each of these three functions here. Starting with function 1, we got f of x equals 5 times e to the power of 4x minus 3. Now I want to do a quick little mini lecture here. So whenever you got e to the a is equal to b, and you want to isolate for this a value, if you want to isolate an exponent, what you got to do is you got to take the logarithm of each side, so you could bring that exponent down. Now, in general, log base e is equal to ln on your calculator, this button here. So what we can do, we have to take the logarithm of both sides with this base. So we would be taking the logarithm with base e of both sides, or the ln of both sides. So ln e to the a equals ln b. And then what we could do is we could bring that a down. We'll have ln e equals ln b. Now, just in general, if we have log, let's put x here, log base x, x, or just anything, this could be a, b, b, just if both of these are the same, that's always going to equal to 1. That's a rule there. So if we have ln e, if you actually input this in your calculator, you'd get 1. And that's because ln is the same as log, so this expression is the same as log base e, which is just equal to 1. So this bracket is just 1. And so basically what we have is a equals ln b. Right? So whenever you got something like this, e to the power of an exponent, and you want to isolate for that exponent, basically that exponent is equal to ln of b. And you can go the other way as well. So let's say we have ln of b equals a, this expression here. If you want to isolate for this, it would equal e to the power of a, right? We'd be going backwards. So just a good rule to remember when you're doing inverses dealing with ln and e to the power of something. So I'm going to write this down here. So you could either be going this way or you could be going that way, right? Depending on the function that you're working with. So knowing that, let's come back to here. So we got y equals 5 e to the power of 4x minus 3. So first step in finding the inverse, we got to switch the x and y. So we'll have x equals 5 e to the power of 4y minus 3. And so what we want to do now is isolate for this y. Notice how it's going to be in the exponent of this e base. So what we got to do is we got to get this expression by itself. So we got to divide both sides by 5. We got to get rid of this 5, bring it to the other side. So we'll have x over 5 equals e to the power of 4y minus 3. And now notice that this is in this format. Okay, so we have e to the power of an expression. Pretend this a is like a whole expression. So this 4y minus 3 is like this a value, and then this x over 5 is like this whole b value. And we're trying to isolate for this, so what we can do is we can use this law here. So basically if 4y minus 3 is this a value, then that means that 4y minus 3 is equal to ln of that b, which was this x over 5. And now notice it's a lot easier to isolate for this y. We bring the negative 3 over, so we'll have 4y equals ln of x over 5 plus 3. Divide everything by 4. So we divide this by 4 and this by 4. And so basically y is equal to 1 over 4 ln of x over 5 plus 3 over 4. Like that. And so that there is the inverse. That's the expression for the inverse of that first function. Another way you can do it is you could have just divided everything by 4. So you could also write this as 1 over 4 ln of x over 5 plus 3. Like that. Right? Keeping that 1 over 4 on the outside. But I prefer to have it like that. So either way works. That is the inverse of this function. All right, and notice that at this point, from there to there, we applied this law. We went from here to there. Okay, number 2, we got what? Y equals 10 ln of 2x minus 5. First step, interchange the x and y values. So x equals 10 of ln 2y minus 5. And so we got to isolate for this y here. So notice that we're going to be going from this to that now, right? Because the variable that we're isolating for is this in this b value. So we got to get that b value by itself. So first thing is we got to get this ln expression by itself. So divide both sides by 10. So we'll have x over 10 equals ln of 2y minus 5. And now notice that this is in this format, where this b value is this entire expression 2y minus 5, and then this a value is this x over 10. So if we go from here to here, what we're doing is we're isolating for the b, so we'll have 2y minus 5 equals e to the power of a, or e to the power of x over 10. Okay, and now we can isolate for this y, bring the negative 5 over, so we'll have 2y equals e to the power of x over 10 plus 5, and then divide everything by 2. So we'll have 1 over 2 e to the power of x over 10, or e to the power of x over 10 all over 2. Both are the same thing, plus 5 over 2. Got to divide the 5 by 2 as well. Another way to do it is you could take this whole expression and divide it by 2. Right? That's another way to write it. But either way, that is the that there is the inverse for number 2. So from here to here, notice we went from here to here. And then finally, number 3, we got f of x equals 3 minus e to the negative x all over 4 plus e to the negative x. So this one's going to be a little tougher. It's going to take more algebra, but it's actually not too bad. So if you see something like this, what's the first step? Well, we got to interchange the x and y. So I'm just going to erase these here. So I interchange the x and y's, and now what we got to do is we got to isolate for this y, but notice that there's 2 of them. So like in a previous video where we had 2 y's, what we got to do is we got to cross multiply. So 1 times 3 minus e to the negative y is just 3 minus e to the negative y equals x times this expression. And then from there, what we do is we distribute that x inside the bracket. So we'll have 4x plus x e to the negative y. This stays as 3 minus e to the negative y. And then what we want to do is we want to bring all the expressions that contain a y to one side, all the other expressions to the other. So this, actually, you know what? I'm going to bring this over there to keep everything positive. And then I'm going to bring the 4x over. So this would be 3 minus 4x, like that. And then from there, what we can do is we can take out e to the negative y on this side. We could factor that out from both of these expressions. It's a common term. This would be x plus 1, 3 minus 4x, like that. Just want to make sure that I didn't screw anything up here. Yeah, looks good. So from here, what we can do, divide both sides by this bracket to get this e to the negative y by itself. So we'll have e to the negative y equals 3 minus 4x over x plus 1. So what I'm going to do is I'm actually going to erase this, give myself some more room, and then write out what I have here. I'm going to put the e to the negative y on the left side. So 3 minus 4x over x plus 1. Okay, so now notice that we have e to an expression equals another expression. If you remember the rule, I actually just erased it. I don't know why, but let me rewrite it again. If I have e to an expression equals another expression, e to the a equals b, and I want to isolate for the a, that's how we isolate for the a when we're dealing with a base e. So notice that this and this are in the same format, e to the negative y, so the a value is like this negative y, and then this entire thing is like this b value. And so if we apply this law over here, this rule, basically we'll have negative y equals ln of all of that. And then we got to just divide both sides by -1 to get the y by itself. So y is equal to negative ln of 3 minus 4x over x plus 1, like that. Another thing, so that's the inverse basically. However, you can actually go further and simplify this if you want. You can leave it like this. I would probably just leave it like this, but if you do want to simplify further, remember logarithm rules. Whenever you have a log of something, that's the same as log of b to the power of a, right? You could bring that a up. So notice this -1 we can bring up to here. So this is like ln of 3 minus 4x over x plus 1 to the power of -1. And if you remember, any fraction to the power of -1 is just that fraction flipped to the power of +1. And it doesn't even have to be 1, it could be any exponent. So -x, and then this would become +x. So if we apply that here, we could flip this fraction, this becomes +1, and then anything to the power of +1 is just itself. So we can actually just write this like that. Okay, so sometimes you'll see textbooks or your prof simplifying even further. So this and this are the exact same thing. We just brought that -1 up to the exponent, and then a fraction to the power of -1 is just that fraction flipped to the power of +1, and then we don't have to write the +1. Another thing is, I've mentioned this before, that this fraction can also be written as ln. We can actually, it's all positive here, so it's all good. Basically what I was going to say is you can rewrite this as -x minus 1 over 4x minus 3. Like if we factor out a negative from the numerator and factor out a negative from the denominator. But the fact that everything is already positive, it's not like x minus 1. It's x plus 1, so it's better to just leave it like that. Right? But basically this, and that are the same thing. I'd say probably the nicer format is this one. So this here is the inverse of that function.